the authoritative DNS server for that IP address range, or if the attacker had compromised the resolving DNS server for the browser, or if some kind of DNS cache poisoning was possible, then this could be useful. I don't consider this to be a really major flaw in the JVM because it does rely heavily on secondary vulnerabilities that aren't all that common. The third method, though, is a lot more powerful. When the JVM is configured to use an HTTP proxy, it will download the applet file, the jar or the class, through the proxy server, but it will still perform a DNS query for pinning purposes. Now, the JVM has no way of knowing if the IP address it receives for pinning is the same IP address that the proxy server received for downloading the applet, which means that if an attacker can coordinate the DNS response so that the proxy server receives the IP address of the attack web server, and the JVM receives the IP address of the victim server, an attack very much like the Live Connect one becomes possible. Of course, this also requires that DNS resolution of internet domains is possible from an internal network, but that's a fairly common deployment. There's a lot of companies that have proxy servers but still allow DNS resolution. DNS and Java are not the only two vectors for launching DNS rebinding attacks. Proxy servers have been suspected to be vulnerable for a while, and last month David Studdard, aka Portswigger, had documented that two of them, popular ones, Microsoft ISA and Squid, are both vulnerable. ISA, Internet Security Acceleration Server, enforces a minimum of 6 minutes for the TTL, basically pins the IP address for 6 minutes, which makes a DNS rebinding attack more challenging, but certainly not impossible. And Squid Cache, in compliance with the RFC, respects the TTLs, but that means that a simple DNS rebinding attack is possible. It's important to note, though, that proxy servers, if they're properly segmented, the risk can be significantly reduced. When a proxy server is used as the victim in an anti-DNS pinning attack, the victim server receives its connection from the proxy, which means that a properly segmented proxy shouldn't be able to connect to internal resources, only out to the internet. But realistically, that's not always the case. Some people don't know this, but Adobe Flash actually has support for sockets also. It's a little squirrely the way it implements it, but they're there. Earlier this year, Kanatoko Anvil documented that Flash doesn't perform any DNS pinning, which again means that simple DNS rebinding attacks are possible. Last week, the security lab at Stanford released a paper on DNS rebinding attacks. It's very good. It covers some other more details on these, and I wish that that they had released it earlier because I would have been able to include some of the new information in my presentation, but I only read it yesterday, so there was not a whole lot that I could do. But I highly recommend the paper. It was very well done and contains more analytical and quantitative data than has been documented in the past. So what about defense? There's several things that have been proposed. Again, the Stanford paper goes into a lot of detail on this, some of which I think are their ideas, and they also repeat a number of other proposals that have been made in the past. One of the ideas is Class C pinning, so that if an IP address switches, it's only allowed to change to a closely numbered address. This could certainly have some benefit, but would break things because sometimes DNS might be load balancing across multiple geographic locations. Another idea is not allowing the DNS record to rebind to a private IP address. This is an excellent idea. There are very few cases where it's legitimate for DNS to change from a public IP address to a private IP address. And in the handful of cases where it is, well, the user can suck it up and restart the browser. Sharing pinning information is a great defense. The idea is that the browser, the plugins like Java or Flash and proxy servers will all communicate using one of several different proposed techniques, what IP address they're using to communicate with a server. And if the IP addresses don't match up, then the communication is blocked. Realistically, I suspect that vendors are going to be resistant to implementing this because it will change the behavior of tools, and vendors are oftentimes resistant to change. A related idea involves defense against the restart attacks involves including the IP address in cached content. Basically, adding IP address to the same origin policy, but only for content that's on the disk cache. Personally, I think that browser security policies are a better way to go in the long run because they're going to address a lot more than just DNS rebinding attacks. Disabling Java might be possible at some organizations, but disabling JavaScript is kind of like driving your car around in first gear. Yeah, it'll get you there, but the internet's not going to be nearly as useful without it. Internet Explorer had a good idea with security zones, but they really haven't taken it as far as they could have. Ideally, an administrator would be able to disable all active content for untrusted sites, allow basic JavaScript for medium, basically anonymous sites, and then for more trusted sites, enable powerful tools like XML HTTP request, Live Connect, and so on. That's supported a bit, but not completely in Internet Explorer today. NoScript can do a tiny bit of that, but very little granularity on Firefox. There's a tool out there called Local Rodeo that Justice Winner and Martin Johns are writing. It's still in beta, basically experimental. It addresses a number of JavaScript security flaws, including anti-DNS pinning. Realistically, though, it's not ready for enterprise deployment, and it's also something that should be integrated into the browser, not provided as a third-party add-on. And that's, no insult intended towards their work at all. Another idea that's been proposed is forcing IP address owners and DNS owners to match, so that if I have an IP address, I have to give permission before a DNS record can point at it. If DNS was being designed from the ground up, I'm sure that would be a significant proposal for the standard. Personally, I think that's unlikely that's going to be retrofitted into the standard, but it certainly would fix the problem. Security gateways, there's some that can add some benefit. For example, there's tools that will block Java applets based on behavior, so that if a applet is going to connect out to a socket, it will be blocked. Speaking from personal experience, those can be very time-consuming to administer due to false positives and also due to exceptions. It's been a few years since I've worked with them, so I'm sure they've gotten better by now, though. A few years ago, a team at Microsoft came up with a list of 10 immutable laws of security. Number one on the list was, if a bad guy can convince you to run his program on your computer, it's not your computer anymore. And while vendors have gotten a lot better at sandboxing active content within a browser, I think that rule still applies and probably will for quite a while. In the end, it might get safer to run programs from strangers, but it's not going to be completely safe. And there are other techniques to bypass perimeter firewalls, like custom-written Trojans. Good security practices is what will provide a broad protection from different attacks. Things like avoiding internal resolution of internet domains. Might not be popular, but it certainly is secure. At the very least, not allowing internet domains to resolve to private IP space or to public ranges that your organization controls, and of course to local hosts as well. That should never be allowed to happen. Network segmentation, while it can be time-consuming to implement, it can still be very effective. John Doe in the call center doesn't need to SSH into your router. Chances are he might not even need access to the internet or to email. Strong protocols that support strong encryption and strong authentication, like SSL, SSH, IPsec, allow tunneling of other protocols over them. And while it's, again, time-consuming to set up, can make it much more difficult for an attacker to spread through an enterprise environment. And finally, if you have a lot of money, which some security departments are blessed with, some of the better application firewalls can actually go a long way in protecting poorly written websites. I wouldn't tell your developers that because it'll just make them lazier, but there's definitely benefit there. And intrusion prevention, it's not perfect, but it can help. Finally, if I did a poor job and you still don't understand DNS rebinding, take a look at this write-up that Christian put on his blog. It's very good. It keeps it simple. Once you understand DNS rebinding attacks, I highly recommend that you take a look at this paper written by the Stanford guys. It goes into a lot more detail than I was able to fit in my presentation. Talks about some other DNS rebinding attacks, and it's very good. That's all I have. If there are any questions, please be gentle. Thank you. And also, actually, if you go to dnsrebinding.net, it will redirect you to the page that hosts this. I probably should have put that up there instead.
Do you ever see these DNS rebinding attacks going on in the real world, or is it more of a theoretical type research thing right now?
Excellent question. I know of only one documented case of DNS rebinding being used, and it was very minor. It was more along the lines of a prank than an actual attack. I have not heard of any of those. Of course, that doesn't mean that it's not happening. Historically, attackers are slow to adopt some of new technologies, new techniques.
I've heard the term anti-anti-anti DNS pinning. Is that
Yes.
something you can explain in
Yeah,
finite time?
so anti DNS pinning, the idea was that host validating host headers could stop it. Anti DNS pinning would be changing the host header using something like Flash, or there's a technique that I think it was a Meet Klein documented for XML HTTP requests, and that's been patched since then.
Hi. You mentioned some of the limitations of ActionScript sockets. What are those?
I'm sorry, say that again?
ActionScript sockets, what are the limitations of those?
The session has to, or the transmission from the server has to end in a null character. The content, if I remember correctly, I'm not an ActionScript expert by any means, but I believe that the content has to be in XML format, which means that and it might support HTTP or HTML, but you're not going to be able to interact binary-wise. And then
isn't that just a limitation of XML sockets? Because in ActionScript 3, they actually have a regular socket for dealing with binary data.
I can't speak to that authoritatively. There's also some limitations based on policies. A server can provide a policy back to Flash that defines what ports it can connect to. By default, if the server doesn't provide a policy, Flash can only connect to ports above 1024, kind of a throwback to the old Unix days.
Mm. All right, thank you.
Sure. Thank you.